Okay, let's start. Okay, circuit theorems. Now in chapter 4 we study about the circuit theorems. Till now what we studied is the basic things. Now in this we studied about the major circuit theorems we have. So we study about linearity property. Linearity property we'll study. One or two examples we'll study in that. How the current and voltage will behave in linearly. Next we'll study superposition theorem. These are the theorems, and next we'll study source transformation. Next we'll study Thevenin's theorem and Norton's theorem. So these are the theorems what we study. Main theorems are superposition, Thevenin's theorem, Norton's theorem, and last maximum power transfer theorem. So these are the 1, 2, 3, 4 theorems we are covering in chapter 4. So yeah. So what we studied till now, as per the magic circuit secrets, Kirchhoff's law are likely magic keys for circuits. They help us understanding them without changing anything. Means directly apply the Ohm's law, directly apply the Kirchhoff's law. Kirchhoff's law, what are they? Kirchhoff's voltage law, Kirchhoff's current law. In this we apply Ohm's law also. So no need of modifying the circuit. Just observe the circuit and write the equations and you will finish it. So this is called magic circuit secrets. Now another we have big circuit math. For that we have big circuit. The math can be super tough. Means if you have big circuits, then this Kirchhoff's laws is not applicable there. Means very tough to apply the Kirchhoff's laws. Now circuits get complicated when think of circuits like puzzles, very big circuits, and in between it's connected, node to node, parallelly connected, series connected, very puzzle like there. Then the circuit become complex over time because we then use in many ways. So we cannot use in many ways because it is very complex. So then what we think now, engineer shortcuts we have to think about. So smart engineers made a special tricks like Thevenin's, Norton's theorem to make a circuit problem easier. If you have big circuit, but I want a analysis for one branch, very big circuit, but I want analysis in one branch. What is the voltage? Every time I am changing, but I want here only. Then what happens? Every time I cannot solve the complete circuit. So we make the complete circuit as a one small circuit. Then the branch where we want to analyze, that is only the final one. So only two branches now. Source and this branch. Now change it, you can get it. So we'll see that one. Circuit rules. Before using these tricks like Thevenin's, Norton's theorem, before using these tricks, let's learn some basic rules like circuit linearity. If you understand the linearity of the circuits, like how the voltage behaves with the current and vice versa, then only you can go for the solving the complex circuit in the simple manner. More tricks, we will also discover the other tricks like superposition, source transformation, and maximum power transfer to make the simple the circuit. So okay, in real world skills we will use all these knowledge to model, source, and measure the resistance in real life circuits. It's like becoming a circuit experts. So we'll see that one, how we can go simple way for the complex circuits. First one we have linearity property. First one, what is the linearity property? Behavior. So linearity is a property of an element describing a linear relationship between cause and effect. Means I do something, what is effect? I do something, what is effect? For voltage and current for any circuit, I change the voltage, what is the current effect? I change the current, what is the voltage effect? That's called linearity. Okay. So the property is combination of both homogeneity, that is called scaling property, and additive property. These two we have to study in the linearity property. What is homogeneity and what is additive property? Okay. Then the homogeneity property requires that if the input is multiplied by a constant, then the output is multiplied by a same constant. Means if the input I am multiplying with some constant, some x factor, then output also must have the same x factor result. Then it is called a homogeneity. It's called scaling also. Means scaling 5% I added, that's scaled. Then output also 5% scaled. That is called scaling, homogeneity, same word. So how it will be? For resistor, for example, Ohm's law relates the input I to the output V is nothing but V is equal to IR. We already know Ohm's law. Now, if I increase 5% of voltage here, will the current 5% will change? Yes, because it's a linear. R is constant. R I am not changing. R once designed, it's constant. 100 ohms resistor is there. 100 ohms only. Now, if I change voltage 5%, current also change 5%. This is called homogeneity, scaling. So, if the current is increased by a constant K, that is percentage or some constant K, then the voltage increases corresponding by K. So, voltage also increase corresponding by K factor. So, that is called KIR is equal to KV. So, R is constant. So, I am increasing with K, though V also will increase with K. Ohm's law. Okay. So, this is called homogeneity. Now, the additive property now coming to. So, additive property requires that the response to sum of the inputs in the sum of the responses to each input applied separately. If we have two things in series, sum of the inputs I am adding. So, the result will be the sum also. You will check. Using the voltage current relationship of the resistor V is equal to I1 R1 and VT is equal to I2 R2 then applying I1 plus I2 gives what will it will give V is equal to I1 plus I2 R, which if you separate it I1 R I2 R. Now what is I1 R? V1. What is I2 R? V2. So here additive property means the resistance is constant but the currents are different, but that current multiplied by resistance is called one voltage and that current other current multiplied by the same resistance is called another voltage, and the voltage both are additive, which is equal to the source voltage. V is equal to V1 plus V2, like that. So this is called additive property. Okay, we say that a resistor is linear element because we know resistor is a linear element. Whatever you change the current, voltage also will change. Because the voltage current relationship satisfy both homogeneity and the additive property. What is the linearity? It must satisfy both things, homogeneity and additive property. Homogeneity means factor of changing voltage must change factor of current. And what is additive property? For the same resistance, if the current is I1 and current is I2, the summation must be V1 plus V2, which is equal to source voltage. This is called additive property. It is given, second one. So this is called linear. If it is linear, then only we can go for the complex circuits to solve easy way. In general, a circuit is linear if both additive and homogeneous properties are satisfying. Now, a linear circuit consists of only linear elements, linear dependent sources and independent sources. So, non-linear things it should not contain. It must contain linear elements, resistor, capacitor, inductor, linear element, passive elements we can say. Linear dependent source. It should depend on any other branch, dependent source. And independent source. Independent source is V is equal to IR, Ohm's law it should satisfy. Dependent source, it will depending on other branch element, but it is linear. So now coming to the linearity property continuation. For example, we have one problem, you can check. Find for the circuit given, find I0 when Vs is 12 volts and Vs is 24 volts. Means every time I am changing here two voltage values. First I am applying 12 volts, next I am applying 24 volts. Then what is the I0 we have to find if it is linear. So all you can check. This is the dependent voltage source. This is the independent voltage source. Now remaining are the linear resistance. So we can solve this problem with linearity. Okay, homogeneity and scaling, that is, and additivity. So these can be solved. Now see the figure. Here how many branches we have? 1, 2, 3, 4, 5, 6, 7 branches we have. Then we can have a 2 loops. So I1 and I2 we can have 2 loops here. Now start the writing the equation for this first loop. I will give you a simple technique here. Writing so many equations become a big problem for you, right? Step by step. Okay, you can solve step by step. It's a good method. But don't confuse when answer is given like this one. It is after solving, it is coming like this. How? For example, loop 1, right? Yeah. First loop. I1 is in which branch it is flowing? 6. 2 and 4, right? Same I1 will flow. Same I1 will flow. And I2 in which branch in this loop is flowing? 4. So separate. What is the I1 in the same branch, same loop? 6, 2 and 4. What is summation of resistance? All are in series. It becomes like a series. 6 plus 2, 8. 8 plus 4, how much? 12, right? So 12 times I1, can I write? 12 times I1. Directly I can write 12 times I1 because the current is flowing in all the resistances, right? I1. Now I2, where it is flowing I2? Only in this loop. In this loop, I2 is flowing in the only 4 ohm resistance. How it is flowing? Opposite. So minus 4 I2. So I can write minus 4 I2. Now this I1, the next voltage equation is entering to the Vs. So it is plus. So plus Vs. First equation. Okay. Or you can write and rearrange also. How? 6 I1 plus 2 I1 plus 4 I1 minus I2 plus Vs equal to 0. Now rearrange. You will get the same 12 I1 minus 4 I2 plus Vs. Same equation you will get. Okay. This is another trick I told you today. Here also the same trick what I told you can do. I2 is a reference. So how many resistances the I2 is flowing? 4, 8 and 4. Right? 3 resistances. So sum all 3 resistances how much? 8 plus 4 plus 12 plus 4. How much? 16. 16 times I2. 16 times I2 is mojud. Next, other than in this loop, other than I2, what is flowing? I1. In which 4 ohm resistance? How it is flowing? Opposite to I2. So minus 4 I1. So minus 4 I1 mojud. Minus 4 I1. Next, bagi itne source mojud. One is source is leaving leaving from here. So minus 3 Vx. Minus 3 Vx. Now source is again leaving from this source. The current is leaving from this source. So minus Vs. So like this we have to write the 2 equations. Clear these 2 equations? Means simple technique. In one set we will finish. Here I am avoiding 3 steps. Other than 3 steps I am directly writing 1 step. Okay. So it will save your time. It will save your page also. Okay. That one. Next. Now. What is Vx? Already we know. What is Vx? Where is the Vx? Here. What is the Vx? I1 only flowing in this resistance. What is the Ohm's law? Vx is equal to 2 times I1. 2 times I1. Vx is equal to, as per Ohm's law, 2 times I1. So now substitute in the Vx here. So it is 2 times I1. So minus 4 I1, 2 times I1, minus 6 I1. So 10. So minus 10 I1 it will become, plus 16 I2 minus Vs as it is equal to 0. So this is one equation. And this is the another equation. Unknowns are I1 and I2, right? Now Vs here, sorry, yeah, plus Vs and here minus Vs. Now you can cancel this one. Make this Vs that side and you can cancel it. You will become cancel these two. Plus minus Vs plus and minus Vs. This becomes 0. Now 4 minus 4 I2 plus 16 I2. What it will remain? 12 I2, right? Yes. Plus 12 I2. So 12 I2. Next, plus 12 I1 minus 10 I1. 2 I1 it will become. So 2 I1 plus 12 I2 equal to 0 because Vs, this equation Vs and this equation Vs will cancel 0. So now 2 I1 plus 12 I2 equal to 0. So what I1 is becoming? I1 is equal to 12 minus 12 by 2. That is minus 6 I2. This is we got relation. I1 and I2 relation. Now what is our question? When Vs is equal to 12 volts, what is I0? When Vs is equal to 24 volts, what is I0? Now where is I0? Where is I0? This one. What is I0 as per this resistance? I0 is nothing but Ohm's law. Ohm's law. I0 is equal to nothing but I2. Right? The same current is what we assume. I2 is nothing but I0. So now, if you substitute this I1 in this equation, we will get I2 is nothing but Vs by 76. Just substitute this I1 in this above equation. You will get I2 is equal to Vs by 76. Now, what is I2? Is nothing but your I0. So, now Vs is equal to 12 volts. I0 is nothing but I2, which is Vs is now 12. So, Vs is now 12. So, 12 divided by 76. Some current will come. That is 12 by 76. Now, So Vs is equal to now 24. Then substitute Vs by 76. 24 divided by 76. So when Vs is equal to 24, I0 is equal to Y2 is equal to 24. That is Vs by 76. That is 24 by 76. So what's happening here? Can anyone see? When Vs is double 12 and now Vs is 24. Okay. Now what is happening to the I0? It is not 12 by 76. Now it is 24 by 76. So it is also double. Is it linearity? Correct. Because scaling is there. Homogeneity is now coming. Right? This is called linearity principle. So it is linearity property. It is satisfying. So like this we have to check the linearity. So now coming to the superposition theorem. Superposition theorem is the superposition principle states that the voltage across or current through, see voltage will be across the resistance, across the higher potential to lower potential, across the resistance. Current is through, juba, through the resistance. It will go from one point to other point. Through the resistance will call. The wording is very important. Voltage, if it means across from higher potential to lower potential. Okay. And current, it is inside, means moving inside any element, maybe resistance, maybe capacitance, maybe inductance, any element, right? So that's why we call voltage across. Current through means inside. So the superposition principle states that the voltage across or current through an element, anything, resistance, capacitance, any element, maybe voltage source, maybe current source, any element we can say. An element in a linear circuit. So linear circuit means what? It must be homogeneity, it must satisfy, it must have additivity. These two it must satisfy linearity. So in a linear circuit is algebraic sum of the voltages across or through the current throws the element. Algebraic sum of the voltage or through the current is that element due to each independent source acting alone. Now let us take, I have one big circuit. In that 5 source voltages are there. Some voltages source are there. Then solving the KCL, KVL, big circuit is there. No, it become problem. Okay, I have to use KCL, KVL, but so many voltage sources, V1, V2, V3, V5, you have to apply. Very big tough. So what we can do now is at a time take the circuit, at a time take only one voltage source. Remaining all remove. Remaining all remove. Now make the circuit easy. Now when you remove all the other voltage sources in any circuit, then what happens? The resistance only remain. The resistance can be solved by series parallel combination. 2 are series, 1 is parallel. Then only voltage source is there. So we can take out the current, Ohm's law. Then divide into the other branches. We will get currents. Now first step. Second step, again put the second voltage source. Remove the remaining all. Then solve the complete circuit in terms of resistances, equivalence. Then find the current with the Ohm's law. Then distribute in all the branches. Like this, 5 times we have to, as per my example, 5 voltage sources means 5 times we have to solve the problem with each at a time one voltage source. So we'll get all 5 different currents. Now sum it all. That is nothing but superposition. Means you are imposing on same resistance, we are imposing many times the current. Means first time one voltage, second time with other voltage source, third time with another voltage source. Now all the currents join in that resistance. So that's called superposition, superimposition we can say. The name coming superimposition means we are adding many things. We are adding many things. So another time I will repeat this one. The superposition principle states that the voltage across or current through an element in a linear circuit is the algebraic sum of the voltage across or current through that element due to each independent source acting alone. Independent source, maybe a current source, maybe a voltage source, independent, anything. So at a time act only one source. We will see the example. So what is the, to apply the superposition principle, we must keep 2 things in mind. What are the 2 things? Open circuit and short circuit. What is it? We consider one independent source at a time while all other independent sources are turned off. Voltage source. When you turn off the voltage source is having V is equal to some X value. If I want to close the voltage source, V is equal to how much? 0. When voltage source is 0, how the circuit will behave like? Short circuit or open circuit? Short circuit, correct. When V is equal to 0, it will act as a short circuit. Okay. Now current source. If I have a current source, if I want to make I is equal to 0, what we have to do?
No resistance. So the voltage will continue.
Really? I think what I am telling is reverse. I think. Check. This implies that we replace every voltage source by a short circuit and every current source with a open circuit. Yes. What you said? Open circuit or short circuit? Current. Current, if I is equal to 0, it's open circuit because current 0 when it happens when resistance is infinity, right? When high resistance is there, then only current it will not allow. So then it will act as a open circuit. In the open circuit, there is very high resistance, current cannot flow. So I equal to 0. Cannot flow means I equal to 0. So that's why it is a open circuit. Current source is open circuit. Voltage source when it has, you have to make short circuit. The complete current it has to flow in that, means no voltage there. So this way we obtain simpler and more manageable circuit. How it will look like. So when V is equal to 0, you have to make it a short circuit, R becoming 0. When I equal to 0, R must be infinity. Okay, so open circuit. So like this we have to think. Always you have to superposition means basic 2 rules we have to come, minimum basic 2 rules. Voltage source I am considering, then if I remove that voltage source, it become a short circuit. If current source I am considering, if you open that current source, it become an open circuit. If you remove the current source, it become a open circuit. Just remove it from there. Voltage source, make short there. Means put a wire there. Plus. Now, dependent sources are left intact because they are controlled by circuit variables. So, we are not finished yet only the independent sources. We have dependent sources also. Dependent sources are 4 types. Current control current source, current control voltage source, voltage control current source, voltage control voltage source. 4 sources we have dependent. So these we cannot touch it. Only we have independent sources. We have voltage or current. Then voltage become short circuit, current become open circuit. So now what are the steps? 3 steps we have. First one, the turn off all independent sources except one source. Let's take n independent sources are there in a circuit. How many should we turn off? N minus 1 we have to turn off. Maybe short circuit, maybe open circuit. Short circuit means voltage source. Open circuit means current source. So n minus 1 independent voltage, n minus 1 independent sources should be turned off. Remaining one. So that one we have to act as a main source and we have to solve it. Okay, find out the output voltage or current due to the active source using the techniques of covered in chapter 2 and 3, like Ohm's law, Kirchhoff's voltage and current law in chapter 3, nodal analysis, mesh analysis. Any technique you can use. Find out what are the currents in the different branches. Second, repeat the step 1, this step, for each other independent source. So let us take, I have 3 independent sources. How many times I have to solve the equation? I have to solve the circuit. 3 times I have to solve the circuit, and in the 4th step I will get the complete analysis. In the 4th step only I will get the complete result. Okay, if I have 5 independent sources, so how many steps I have to follow? 6 steps I have to follow. 5 steps for solving individually for each source. 6th step to join everything. Okay, so like this. Now repeat the step 1 for each of the other independent sources. Next, last one. Find the total contribution by adding algebraically all the contribution due to the independent sources. Simple steps are there. Step 1, check. Is it a voltage source or current source? So if it is a voltage source, short circuit. If it is a current source, open circuit. This is step 1. Keep in mind. Don't apply now. Keep in mind. Now, what is the next step? Check how many sources are there. If let us take 3 sources are there, for example. Okay. At step 2, keep that one of these 3 sources keep active. Remaining 2 sources make open. Off. Make off. Make off means voltage source short circuit, current source open circuit. It doesn't mean that 0. Okay. So voltage source, if it is there, short circuit. Current source, it is there, open circuit. So now only one active source out of the 3. Now solve the equation, solve the circuit, get the currents in each branch, then keep aside. Then second source, keep the second source, what we have assumed, which is the second one. Keep the second source active. Remaining first and third source make off. Off means same rule. Short circuit voltage source, open circuit current source. Find the branch currents, branch voltages, then keep aside. Next, third also same. Last one. Third, independent voltage source or current source, whatever you assume, keep that active, remove, or we can say off the first and second one by the rules. Short circuit voltage source, open circuit current source. Find all the voltages and currents in the branch. Now, step last. The last step is join all these 3 results. Then you will get the final result. So, like this we can remove the complexity to make the 3 simple steps if we have 3 sources. Okay. So, we have an example now. So, first example. Okay. This is a simple one. The big will come. So, what we have, 2 voltage, 1 voltage source and 1 current source is there. 8 ohms and 4 ohms. Now, here one problem is coming because I didn't explain you the super node. I didn't explain you the super mesh, right? What is a super node? Node analysis. Which source we used to have current source or voltage source? Node analysis. Node analysis. Which source we have? Current or voltage source?
Because the mesh depends for the loops.
Yes.
So depends for
Opposite. Node analysis always have current sources. Mesh analysis always have the voltage sources. Node analysis have the current sources generally. Okay. We solve all the problems with the current sources, and mesh analysis always have voltage sources. If it is both mixed are there, we have to go for these techniques: superposition, maximum power transfer. These techniques we have to go. Okay. Now, here we have 1 voltage source, 1 current source. Now tell me, what is our technique? At a time, only 1 should be active. So, let's think. First one. What is we need? Okay, use superposition theorem to find V. Where is V? In this 4 ohm resistance. This V we want to find. So, by using superposition theorem, V should be equal to V1 plus V2. What is V1 plus V2? V1 is when the one source is active. V2 is nothing but when other source is active. So, V1 plus V2. So, next, which one is 1 and we have to take? Yeah. So, I am taking 6 volts as a first source and this is the second source. So, when you take the active as this first source, then what is the second source? This is a current source. So, when it is a current source, what is the rule? Open it. Open it, right? If it is a voltage source, short it. Okay, join the 2 terminals. Then if it is a current source, that's why just remove the current source and open the circuit. See, this is the terminals we are opening, just removing it. We will see the next when we consider this current source and removing the 6 volts. We will check it. Now, simple circuit now. This is your loop, I1. So, what is the equation? 8 plus 4, how much? 12 I1. No other currents are there. So, 12 I1, current is leaving. Minus 6 equal to 0, or I1 is equal to nothing but how much? 12 divided by 6. How much? 2 amperes. Simple, right? Check. Sorry, 12 I1 minus 6 is equal to 0. Sorry, I1 is equal to 6 by 12. Sorry, that's reverse. 0.5 ampere. Simple equation. 12 I1. That is where from 12 I1 is coming. 8 plus 4. I1, no other resistance. So 12 I1 minus 6, which is a voltage, equal to 0. So rearrange this one. 12 I1 is equal to 6. I1 is equal to 6 by 12, 0.5 amperes. Okay. So we got 0.5. Now when it is a 0.5 amperes, what is a V1? Ohm's law. What is a V1? Ohm's law. V is equal to I times R. What is I? 0.5. What is 4? Resistance R. So 4 into 0.5, how much? Itne? 2 volts. So V1 will, now in this V equal to V1 plus V2, V1 we got how much? 2 volts. V1 we got 2 volts. Okay. Now next, get the another one. First one is class. V1 we got it with the first assumption, that is removing the second source. Now keep the second source and remove the first source. Check. What we have to do in this, I am keeping this current source as it is here. Now I am just making this voltage source to be off. When the voltage source should be off, how it will be off? When it becomes short circuit. V is equal to 0. V is equal to 0 means it becomes short circuit. Now here we got this one. So in this again, here we can use node analysis because these are parallel. See, and this is the current. Loop means 1, 2 loops we have to make. It become problem, right? Node, only one node is enough. So what is the node here? If you take current, I2, because already I put I1 here. So don't confuse with what is I1, I2, I3. Once now serial wise, if you are writing I1, I2, I3, just use that one only. Don't copy the same I1. Again, I will use here also some other thing, same I1. No. One I1 is I already considered here. I1 is khalas. Next, for the second circuit, I start with I2, I3, I4 continuation. Easy for you for calculation. Otherwise, you will become confused. Now, in this, I assume this is the I2, and in this resistance, I assume I3. Now, this is the current 3 amperes. It's coming. Now, at that node, what is the incoming currents? 3 amperes. What is the outgoing? I2 and I3. So, node analysis. What is the equation can I write? 3 equal to I2 plus I3. Now, what is I2?
8 I3.
Yes. No, we have to find I2 and I3, right? Now, what is I3 as per the previous equation? Already we got I3, which is equal to I1. I3, what is I3? Here in this, what is I3? Same. The current what we have, that is 0.5. Just substitute there. So, we will get I2. Okay. So, like this, find the I1 and I2. Now, to get V2, we have voltage source and find using the current division. Okay, directly also we can use what is I3 here. How can we find I3 here? It is directly current division. Total current how much? 3. Total current 3. And what is the current in this resistance? As per the current division rule, other resistance divided by total resistance into 3 amperes total current. Other resistance 8 divided by 4 plus 8 total resistance into total current, which is equal to 2 amperes. So this is another technique. Okay, first technique I told you node analysis. Now this is the another technique. So we can have the I3. Now next V2. V2 how can we find? V2 is nothing but I3 times R, Ohm's law. I3 times R, that is 4 ohms. So 4 into I3, so 8 volts. V2 is 8 volts. Now final answer, V is equal to V1 plus V2. What is V1? We already got 2 volts. What is V2? 8 volts. V1 is 8 and V2 is 8, V1 is 2. So sum it, total voltage is 10 volts. So in this simple 3 to 4 steps, you are finishing. Okay, no need to go for the loop analysis, many things, no need. Complexity, Cramer's rule, no need. Directly we can solve this in this simple methods. This is called superposition. Now another example, then we will finish this class. Okay, find I0 in the circuit. It's a slight bigger one because we have 3 sources. One is current source, independent. One is voltage source, independent. Another is current source, dependent. Okay, this is a dependent. Now, so how many steps we need here now? How many analysis we need here now? 3. Why? Because we have independent only 2. 3. No, 2 independent sources are there. One is dependent. So dependent source we should not touch. So we need 2 circuits with each one.
So we have
two analysis, and third analysis, third step, complete answer. So 3 steps, total 3 steps. So in first step, what we have to, which one you consider? Let's take I0. We want I0 means I0 dash, we can say, and I0 double dash, I name it. Whatever you want, you can name it. I01 also you can name, I02 also you can name. I put dash on the top, no problem. I0 is the current in the 5 ohm resistance is nothing but I0. Now with the superposition principle, that I0 is nothing but I0 dash plus I0 double dash. So I0 dash when I consider 4 amps current, and I0 double dash when I consider 20 volts source voltage. Okay. Now let's see. So what happens? I am considering now this as a first source. So this is a voltage source which I have to make it off. Make it off means V is equal to 0. When it will be 0? When it become short circuit. This is a voltage source. I take this 4 amperes in the circuit. I want to remove these 20 volts. I want to remove these 20 volts. The voltage source, what we have to do? We have to make it short. See, I made it short here. I keep this one first. Later, what you told, okay, later I keep the 20 volts, I will remove this one. It will open. That will come later stage. First stage, I consider 4 amperes. Any first step you can take. Either this source or that source, up to you. But I consider 4 amperes as a first circuit, and I want to remove these 20 volts. So 20 volts now becoming 0. That is short circuit. Now this is your first circuit. Now what are the loop equations? Current I1, I2 and I3. Right? Now directly I1 is 4 ampere directly is there. So no need to write the loop equation here. Directly I1 is nothing but 4 amperes. You have to write the second loop equation and third loop equation. So what is the second loop equation? I told you the technique. Second loop. In this loop, all the resistances, all the resistances, which current is flowing? I2. So sum all the resistance. 3, 4, 5, 6. So 6 I2 will be there. In 3 ohms, another current is flowing. Minus 3 I1 will be there. In 1 ohm, another current is there. I3. So minus I3 is there. So now current is leaving this one. Minus 5 I dash. I0 dash. So it become, see, minus 3 I1. That is, in this current is flowing, minus 3 I1 plus 6 I2, 2 plus 3, 3, 4, 5 and this one, 6 I2 minus I3, because in this resistance I3 also flowing in opposite direction. So minus I3. Another source is there here, dependent source. What is it? Current I2 is leaving from this plus terminal of this dependent source. So 5 I0 as it is, 5 I0 dash. So this is one equation now we got. Now from this you can substitute what is I1, 4 amperes. Now rearrange the equation in terms of I2 and I3. That is later. Now next, another loop. What is another loop? Second loop. Last loop, sorry, third loop, I3. So in I3, I told you the same technique. What are the resistances in which I3 is flowing? 5, 1 and 4. So 5 plus 1, 6 plus 4, 10. 10 I3 plus 10 I3. Next, in this 4 ohms, no other current. In this 5 ohms, other current is flowing. That is I1. So in opposite. So minus 5 I1. In this resistance also, another current is flowing. That is I2. So minus I2. Okay. So minus I2. So total we got 3 terms. One is 5 plus 4. 10 I3 minus 5 I1 minus I2. Next we got a source here. Current is entering now. So plus 5 I0 dash equal to 0. Plus 5 I0 dash equal to 0. Now rearrange this one. I1 already we know. What is I1 here? 4. Okay. Now substitute the 4. Now another thing. At node 0. At node 0, what are the currents? At this node 0, what are the currents I can take? I1, I3 and I0. What are the entry? I0 dash is the entry. I3 is the entry. So I0 dash plus I3 equal to I1. Or I3 equal to I1 minus I0 dash also we can write. So I3 is nothing but 4 minus I0 dash. Substitute and rearrange this one. You will get these two equations. The first equation you got this one. From the second equation you will get this one. So next you get I0 dash as 52 by 70 amperes. We got first current. Now go to the second setup. What is the second setup? Remove the first source, keep the second source. What is the first source we assume? Current source. So removing the current source means open circuit. See, open circuit. We are removing the current source, open circuit. Now, here this voltage source I am keeping as it is, 20 volts. Now this is your second circuit now with the second source active. That is 20 volt source active. Now write the two loop equations only here. Two are the. So I4 and I5 we have to find. So what is I4? We can write I4. Same. 3 plus 1, 4, 5, 6. 6 I4 minus I5. Current is leaving here from the plus. So minus 5 I0 double dash. 6 I4 minus I5 minus 5 I0 double dash from the first loop. Second loop, what will have? Sum all the resistances. 5 plus 1 plus 4, 10. So 10 I5. 10 I5 you will get. Then first one. Yeah, 10 I5. Here only one current. Here also only one current. Here is two currents are there. So 10 I5 minus I4 and current is entering. So plus 5 I0 double dash. Then current is leaving minus 20. So minus 20. So another equation will come. So minus 20. So minus I4, that is because of this. Because of this minus I4, current is opposite to the I5 minus I4. Then total resistances 10 I5 minus 20 plus 5 I0 double dash. So is equal to 0. Now rearrange with this equation 9. We know that what is I5? I5 is nothing but minus I0, opposite to this one. I5 is nothing but minus I0 double dash. So substitute, because we need I0 double dash. Okay, not I1, I2, I3. We need I0 double dash only. So substitute I5 is equal to minus I0 double dash in the previous two loop equation. This loop equation. Then you will get these two final equations. That is 6 I4 minus 4 I0 double dash equal to 0. Then I4 plus 5 I0 double dash equal to minus 20. Now rearrange this and solve this equation. Two unknowns and two equations. You will get the values. What is I0 double dash? Minus 60 by 17. Because current what we assumed is downwards. But what is flowing upwards. So that's why the result is coming minus. What we assumed here, current I0 double dash downwards. But the loop current, how it is? Upward. Because the current voltage source is coming here and moving upward. So it is minus 60 by 17. So what is the total current I0? I0 dash plus I0 double dash. We know that the original circuit, what is I0? Is nothing but I0 dash plus I0 double dash. I0 dash plus I0 double dash. So we have I0 dash with the previous circuit, that is 52 by 17. I0 double dash we already have minus 60 by 17. Now just sum it. So 60 minus 52, it is 8. That is minus 8 by 17. If you divide it, you will get this current. So like this you have to find with different circuits. First circuit with active one source. Second circuit with other source active. So like this we'll find and we'll sum it. Algebraic summation of the voltages or currents to that particular element with a active source at a time 1. Okay. So source transformation we'll study in the next class inshallah.